All right, let's dive right in. We're going to unpack a security story that hits right at the foundation of, well, pretty much the entire modern internet: containers. We're talking about a flaw that could let a single app break out of its digital cage and basically take over the whole server. So yeah, it's a big one.
Think of it like this. Every app on a server gets its own private, secure room. Everything it needs is inside, and the door is locked tight so it can't just wander around and mess with other stuff. But what if that room had a secret, unlocked door? A door that leads straight to the building's master control panel. And that right there, that's the heart of the problem we're exploring today.
Okay, so to really get how this escape is even possible, we first need to understand the fortress itself. Let's get our bearings on what these containers really are, and who or what is supposed to be guarding them.
So a container is pretty much exactly that secure room we were talking about. It's this neat, standardized package that bundles up an app's code with all the files and libraries it needs to do its job. This gives it an isolated, super consistent environment no matter where you run it. It's really the magic that makes so much of modern cloud computing just work.
And of course, every fortress needs a guard. In the container world, that guard is a tool called runC. It's the low-level workhorse that does all the heavy lifting of creating and running these isolated rooms for the big players like Docker and Kubernetes. Its most important job? Enforcing that isolation, making sure the door stays locked. And this entire story hinges on a moment where that guard gets tricked.
Now for the other key piece of the puzzle, the master control panel. On a Linux system, this isn't some physical box with levers and shiny buttons. It's actually a special kind of folder. Let's take a closer look.
This is Procfs, and it might look like just another folder with files in it, but it's not. It's what's called a virtual file system, and it gives you a direct window into the kernel, the absolute brain of the operating system. If you can write to certain files in here, you can literally change how the host system behaves on the fly. It really truly is the master control panel.
So that brings us to the big, scary question. What happens when a piece of software that's supposed to be locked up tight inside its container finds a way to reach out and start flipping switches on the host's master control panel? Well, suddenly, those fortress walls don't matter much anymore.
And that is exactly what a recently discovered set of vulnerabilities allowed an attacker to do. And we're not talking about a small crack in the wall here. This was like finding a detailed blueprint for a full-blown prison break.
Here's the official case file. We're looking at 3 different but related vulnerabilities. And just look at those CVSS scores. All are an 8.2 out of 10. In the security world, that is a huge blinking red light that screams high severity. They each use slightly different tricks, but they're all after the same dangerous prize. The official security advisory from researcher Alexa Sarai really says it all. These flaws allow for full container breakouts. I mean, that's not just peeking outside the room, that's kicking the door off its hinges and taking over the entire building. So let's break down how one of these attacks actually works. It's a classic bait and switch. See, to protect the host, runC tries to block off a sensitive file by covering it with dev/no, which is basically a digital black hole. But in a tiny, tiny window of time, we're talking microseconds, an attacker can swap that black hole with a symbolic link, which is just a redirect sign. This new sign points to a really powerful host file. So when runC goes to finish the job, it's been fooled. It just follows the attacker's redirect sign and, whoops, it gives the container write access straight to the host's control panel.
The other vulnerabilities? They're basically playing the same game, just with slightly different rules. They all rely on something called a race condition. It's like a digital sleight of hand that happens in a blink of an eye. The attacker is literally in a race against runC while the container is being set up. And if the attacker wins that race, they can trick runC into creating the flaw that gives them access to that all-powerful Procfs control panel.
So, why does this all matter? Well, the impact is pretty much as bad as it gets for container security. A successful attack means the attacker can totally escape the container's isolation. They can run their own code directly on the host machine itself, and from there, they can steal data from other containers, shut down critical services, or just gain complete control of the server. Game over.
Now, a vulnerability this severe demands a response that's both fast and really, really careful. What happened next is actually a fantastic example of the open source community coming together to defuse a ticking time bomb. This timeline shows what we call responsible disclosure, and it's crucial for preventing total chaos. Instead of just posting the exploit online for anyone to see, the researchers privately reported it back on October 16th. That kicked off a secret embargo period.
Behind the scenes, developers were racing to build fixes and were quietly sharing them with major cloud providers. This gave the big players a chance to get ready. And only when the patches were available for everyone, on November 5th, was the vulnerability announced to the world.
And these are the people we all have to thank for that. Security isn't magic. It's the result of incredibly hard work by dedicated, smart people. This was a global, collaborative effort. You've got researchers from companies like Huawei, SUSE, and Docker, plus independent contributors, all working together to find, report, and ultimately fix these critical bugs.
And you know, this wasn't some simple one-line fix. To really truly secure the fortress walls, it took more than 20 individual patches. Just think about that. That number alone tells you how complex and deep this problem really was, and it highlights the massive engineering effort it took to properly defend runC from this kind of attack.
So, the alarm has been sounded, the fixes are out there. Now let's get to the most important part, what you can actually do to fortify your own digital fortresses.
Okay, number 1, top of the list. The most critical thing you can do is simple. Update runC. Seriously, if you do one thing after this, do this. The patched versions are out and available. If you're running any system that uses containers, you have to make sure you're on one of these versions or a newer one. This directly closes the hole that the attackers were trying to get through.
But beyond just patching, this whole event is a huge reminder about something called defense in depth, the idea of having multiple layers of protection. For instance, using features like user namespaces creates another barrier, making sure that even if an attacker gets out, they don't have the high-level permissions to do real damage. And even simple stuff like not running processes as the all-powerful root user inside your container adds another critical layer of safety.
And this, right here, might be the most crucial takeaway for anyone managing these systems. The security advisory itself points out that these attacks are only possible if you are running untrusted code in the first place. Your first and best line of defense is always to make sure you know and trust the software you're putting inside your containers.
You know, when you step back, this whole story is a powerful lesson about modern security. It really shows that the safety of our digital world depends on two things: the quality of the code that builds those fortress walls, and just as important, the vigilance of the global community that guards them, always checking for cracks and working together to patch them up before they break.
And that kind of leaves us with a final thought, right? As more and more of our digital lives move inside these containerized fortresses, the stakes just get higher every single day. This was a near miss, and it was stopped by an amazing community effort. But it leaves us with that critical question. In a world now built on containers, how do we make sure the walls will always hold? It's something we all need to be thinking about. Thanks for tuning in.